Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I'm learning quickly, I don't claim any real expertise. Today, we're looking at the 77th Project Euler problem. As always, I will link to both the problem and my repository in the description. Let's dive in. Problem 77 is prime summations. It is possible to write 10 as the sum of primes in exactly 5 different ways. 7 plus 3, 5 plus 5, 5 plus 3 plus 2, etc. What is the first value which can be written as the sum of primes in over 5,000 different ways? So the first thing to notice in approaching this problem is that it is actually quite similar to problem 76. Let's look at that one right now. So in problem 76, it was given this particular number. How many ways can you write it as a sum of at least 2 positive integers? Which obviously isn't quite exactly the same thing as a sum of primes, but the math to find the answers are quite similar. And because 100 can be written as a sum of at least 2 positive integers in millions of ways, it is very likely that the answer to problem 77 is relatively small, because we're looking for the first number that can be written as a sum of primes only in over 5,000 different ways. So let's go ahead and let's see. So here's problem 76, and we're going to go ahead and create the file for problem 77. Add that. And we're going to be doing something pretty similar here. I'm going to go ahead and copy the code for this. But the way that we're going to implement this is going to be a little bit different because of the primes. That's why I didn't copy the formulas over. So in this case, our formulas are going to be more like this. So f of n is the number of ways n can be represented as the sum of at least 2 primes. F of nx is the number of ways n can be represented as the sum of primes starting with x. X has to be less than n. And then I have a few examples here where f of n is equal to f of n2, f of n3, f of n5, etc. to f of ny, where y is the largest prime smaller than n. And then f of 2 is always 0, f of 3 is 0, f of 5 is 1. F of n2 is 1 if n is even, and 0 if n is odd. F of n3 is f of n minus 3, 3, plus f of n minus 3, 2, which is actually a little bit better to put these in the opposite order, just for the way I think. And then this generalizes into f of nx is equal to f of n minus x 2 plus f of n minus x 3, etc., etc., where n minus x is greater than x. And f of nx is equal to f of n minus x plus 1, where n minus x is less than or equal to x. So, okay. Count sums. Okay, so how this works is If n less than or equal to 3, return n minus 1. Okay, so we actually want if n less than or equal to 3, we return 0. And then we have for I in range 1n, sum plus equals count sums largest to x in I. Okay, so we have to switch this out. We have to know what our primes are, and we have to count by primes instead of by ones. So let's see. Right here, we're going to have a primes array, and then we're going to have an is prime array. And let's see. Our is prime array, we're going to use this method that we have used before. Basically, we just want to know exactly what prime is. And I'm going to have the limit be 100 because I do think that the answer is less than 100. And I'm also going to have a variable called target, which is 5,000 because we want over 5,000 different ways. Okay, so what this will do is it will go through and it will find all of the primes that are less than 100. And I'm actually going to do this array. I'm going to declare lower because all the primes array is I for, or let's say call it P. P for P and prime is prime. Or, yeah, actually it is going to be I for I in range. If is prime I. So if I is prime, throw it in the primes array. And here, instead of doing for I in range like this, we'll say for P and primes, if P greater than or equal to N, then we break. Otherwise, we do sum plus equals count sum largest to X. And this next has to be a P. If X greater than or equal to N, this should never actually happen, but just to be on the safe side. Then let's see. If X equals 2, return 1 if in mod 2 equals 0, else return 0. X equals n minus 1. Well, can't just return 1 there. So not that special case. And not this special case either. So if X is less than or equal to n minus X, then here again, we're going to have the same loop. I should not have done it that way. Okay, so if p greater than or equal to plus 1, I think. No, just greater than or equal to x. Then no, just greater than x. Then you want to do n minus x p. Okay. Otherwise, we count sums for n minus x plus 1. Oh, this should be x greater than n minus x, actually. And then otherwise, it's just that plus 1. Okay, so we're going to go ahead and start with 10 to make sure we have the correct answer here. Okay, so 5 is 5 the correct answer? Yes, it is. So now, here's where things get a little bit more difficult. So I'm going to say n equals 10. And then I'm going to say for while n less than or equal to limit, count equals count sums n, and then if count greater than the target, then print found count of for n of n. And then break. And that'll be it. So let's see how quickly we get there. This might take a little bit to run. I'm not 100% confident that it'll run within the minute limit. But I'm also not 100% confident that it will give the correct answer. But let's let it run for a little bit and see. Actually, I want to be able to see it working, so I'm just also going to have another if inside here. If n mod n equals 0, then print true n equal n. Ah, so I built an infinite loop there. And what I want to do is I want to increment n by 1 every time. Okay, so that obviously ran through in like less than a second. Let's see if 36 is the correct answer. It is not. So obviously my count is off somewhere. I don't want to go all the way up to 36 to see what the problem is. Let's see. Okay, I think this condition is where I have it wrong. Because this actually should be less than or equal, I believe. Let's see if that gives us a different answer. Okay, so that gave us an answer of 71. Um, let's see if that is the correct answer. And it is. Okay, so once again, it's the little things like this. I had actually written down the formula incorrectly. Or, no, I had written down the formula correctly and then interpreted it incorrectly when it was converted to x compared to n minus x instead of n minus x compared to x. But in any case, there we go. I'm going to call it there for this one. And yeah, if you want my help with any code challenge you are working on, feel free to use the link in the description, and I'll see you in the next.